take a look at this kind of strange little concept called the difference quotient. Now, the difference quotient is just about the same thing as finding the slope between 2 points. We know the slope, m, is y2 minus y1 over x2 minus x1 when you're given 2 points, x1 comma y1 and x2 comma y2. That's our slope. We all know this. This is algebra 1 stuff. That's great. So now we're going to look, in this video, we're going to look at the difference quotient. And the difference quotient looks kind of funny. We're going to take a minute on the next slide and actually go over what it's saying. But the difference quotient is that f of x plus h minus f of x all over h, that this would be the slope of the secant line on a graph. So, looks a bit weird, but we're going to take a look at this. We'll be all set with it. So here we have a graph, and we've got on this graph, it's some arbitrary curve, and we've got a point here, we've got another point farther along it here. And what we want to do is we're going to find the slope of the secant line. The secant line is a line that connects these 2 points. So we're going to find the slope of this line. And we're going to change a couple things from what we'd normally do to find this slope. So we're going to just call this value here x. And it could be, doesn't matter what number it is when we're working through it, we're just going to call it x. So that means that this point here, the coordinates of this point are going to be x, comma, f of x. And then we're going to take a look at this point over here. And instead of calling it x2 or some other value, we're going to find the value of x slightly differently. And what we're going to do is we're going to measure, or discuss at least, this distance here on our x-axis, the distance between the 2 points. And we're going to call this value here h. So we're going to say that h is the distance on the x-axis between our 2 points. So now when we define this point over here, instead of saying x or whatever else, if we know that the distance from the origin here to x is just x, that's how we graph a number, and then the distance from this point to our other point is h, we're going to say that this point, this x coordinate is x plus h. It's this distance plus the additional distance x. And then our y value here is going to be f of that first part of the coordinate. So f of x plus h. So now, when we would look at slope, we knew, slope m is y2 minus y1 over x2 minus x1. We're going to look at this as x1, y1, and this as x2, y2. So the first thing we do is we find the difference between the two y coordinates. So f of x plus h minus f of x. So we get f of x plus h minus f of x all over, and we're going to subtract the x coordinates, x plus h minus x. So x plus h minus x. And you can see it started to take shape from what we were talking about before. And the last thing we're going to do is we're just going to simplify this denominator. X minus x, they add to 0, they cancel out. So we're left with, numerator stays the same, f of x plus h minus f of x all over h. And this is our difference quotient. That's how the formula comes from. So we get it. Now, this might seem ridiculous, because why would we do this? We know how to calculate slope. If we're trying to calculate the slope, why make a function of it? Why not just do it the way we've done it since algebra 1? But there is a reason for that. And to see that reason, we're going to go to a very little diagram I drew over here. So this is a little thing here. We've got slope over here on this side, and we've got calculus over here on this side. And they're two separate things. And the difference quotient is the bridge from slope hang on, I can draw this. I'm very good at drawing. This is a bridge, and this is the difference quotient. And what the difference quotient is going to let us do is we're going to use the difference quotient for quite a while, or something very similar to it, to go from slope over to calculus.